So now we want to look into these fractional powers or rational exponents. All right. So 9 to the 1/2, that's an exponent there. So what does 9 to the 1/2 times 9 to the 1/2 mean? Well, I don't know what 9 to the 1/2 is, but we know we got a rule, a power rule that says we got to add those exponents. So that gives us 9. 1/2 to the 1/2 is to the first. So whatever 9 to the 1/2 is, I don't know what it is, but when I multiply it by itself, I get 9. 9 to the 1/2 times 9 to the 1/2 is 9. Okay. Well, we can also say 9 to the 1/2 squared. What does that mean? Well, our power to power rule there says we multiply those, right? We take 1/2 times 2 because it's a power to power. So now we have 9. 1/2 times 2 is 1. So I don't know what 1/2 is, 9 to 1/2 means. That's kind of a weird thing. But I have something that when I square it, I have some number that when I square it, I get 9. Well, do you know what number we can square to get 9? Well, that number is 3. So 9 to the 1/2 must be worth 3. Interesting. Let's try it with a third power. What in the world does 8 to the 1/3 power mean? Never done fractional exponents like that before. All right. So, well, what that means, according to our product rule, is we got to add those exponents. 1/3 plus 1/3 plus 1/3 is 1. Or if we have 8 to the 1/3 to the third, well, that power rule there says that 1/3 to the third, we multiply those, and that's 8. 1/3 times 3 is 1. So in other words, I don't know what 8 to the 1/3 means. That's kind of new, but something to the third power, this something, I don't know what this something is here, equals 8. Oh, wait a minute. We know what that something is. That something has to be 2. So in other words, 8 to the 1/3 power must be 2. Well, what's going on? Well, so this is really just the cube root of 8. This is really just the square root of 9. All right? So 1/2 is really just a square root. Cube roots, 1/3 just ends up being a cube root. And I'm betting a 1/4 would be a fourth root too, huh? So we can convince ourselves that when we have a fractional exponent, a to the 1 over n, that just means this is going to be the nth root of a. So fractional exponents are just another way to write radicals. So let's try a little bit of that. What does that mean? So now that we know that these fractional exponents are a radical, so 27 to the 1/3 means the cube root of 27. And we know the cube root of 27 means what number to the third power gives us 27. And if we think through it, that's 3. Well, what about negative 32 to the 1/5 power? Well, that just means the fifth root of negative 32. And we ask ourselves, what number to the third power equals 32 or negative 32? And that would be negative 2. Okay. Then we ask ourselves, all right, what about this 1/2 power? Well, first thing we can do is we can apply this to each of these. So we have 36 to the 1/2, which we'll think about in a moment. Then we have x cubed to the 1/2. Well, that is x. Now we have 3 times a half. A little review there. That's like 3 over 1 times a half. Multiply straight across. That's 3 halves. So 3 times a half is 3 halves. All right. And then we have, whoops, not yet. We have the 6 to the 1/2. Don't forget that. So 6 times a half is 3. So we have a y to the third. All right. A little bit more cleanup here. What does 36 to the 1/2 mean? Well, that's just 6. And then we have x to the 3 halves. We'll leave it like that for now. And y to the third. All right. We'll talk more about that 3 halves in a second. So there we go. We can simplify things that are numbers. And we can also simplify with variables. All right. So now we're going to start going back and forth with these radicals and with these fractional exponents. Okay, so let's write in radical notation and simplify if possible. All right, well, what if we have, now notice these were these 1/2, 1/5. Well, what is this 3/2? Now this fraction doesn't have a 1 on top. Okay, well, what's going on there? Well, let's think about it here. We want to write these in radical notation and simplify it if we can. All right, so 8 to the 4/3. Well, that's kind of like 4/3. 4/3 is like 1/3 times 4. 1/3 times 4. Okay, 1/3 times 4 is the same as 4/3. Well, that's the same as 8 to the 1/3 to the 4th power, because remember, when we have power to power, we multiply. All right, well, that's 8 to the 1/3 we know is 2, and we have this 4th power still. So we have 2 to the 4th, and 2 to the 4th is 16. 2 times 2 times 2 times 2, 16. All right. Now we could have also said it like this. Could have also said that this is 8 to the 4 times the 1/3 power, right? Because 4 times 1/3 is the same. And that's 8 to the 4th to the 1/3. And if we do that, is 4,096. All right, 4,096. Well, the cube root of 4,096, let's try that. So we have, this is on our Desmos calculator. So we got to go to our cube roots. So the 1/3 power means the cube root of 4,096, and that's 16. Okay, 16 is what we got before. So now that was a lot more work to do it that way. So it'd be a whole lot easier to take the fractional power first there. In other words, the cube root first, drop it down, and then go up there. So we'll take the root first. Now, by the way, here, let's go back to our calculator, and I want you to see that we could have gone straight to 8 raised to, so you're going to hit this exponent key. This is on Desmos. On your graphing calculator, you'll have x to the nth power. It should say x to the nth power. Okay, and then we've got to use in parentheses. That's important. So we're going to put in exponents in our parentheses. So let's go back up here. X to the parentheses 4 divided by 3. Okay, and we'll close those parentheses, and we get, there's our 16. Okay, so when you do 4/3 powers on your calculator, you got to put it in parentheses. But you can do the whole 4/3, and it can figure out that that's 16. Okay. All right, so we saw this. It's going to be a whole lot better if we do 25 to the 1/2 to the 3rd power. You want to do that first. 25 to the 1/2 is 5 to the 3rd power, and that's going to be 125. Okay, so take the radical first. Do the radical first. Yeah. Okay. What about this? 27 to the 2/3. Okay, so this is going to get applied to both. So we have 27 to the 2/3, and we have x, and I'll just write it out for now, 3 to the 2/3. Well, 27 to 2/3 means the cube root of 27 squared, and let's go ahead and do this. 3 times 2/3, that's like 3 over 1. And when we multiply 3 over 1, we get 6 over 3. 6 over 3 is 2. We can also think of canceling there if you have experience with that. And this is going to be 3 squared. 27 to 1/3 is 3. So we have 3 squared times x squared, and 3 squared is 9. So we're starting to see how we can really apply all those exponent rules there. So Little definition here. So what we see is we see that when we have x to the m over n, that m power is going to be, or a, I said x, should have said a, is going to be on the, it's going to be a power, and that n, which is in the denominator of the fraction, is the index. And so we can take this, and we can take a to the m power, and then take the nth root of it, which when we talk with numbers, that's kind of messy. If you're talking numbers like our examples we just did before, then if we have that m power there, oops, that m power is going to be an exponent, and that denominator n there is going to be the index. So the key is the denominator is the index. So that's the key. The denominator is the index of the root. Okay. All right. So now we can go back and forth from rational exponents to written out explicitly. Okay. So now we have, what does this mean? Okay, now the directions just want us to write this with rational exponents. Rational exponents are fractions. All right, so the denominator is the index, and the index here is 5, so that's going to be our denominator. And so this is 7 to the 7/5. We don't want to not worry about figuring out what it is right now. Okay, well, what about here? Well, here the denominator is the index, so the denominator is going to be 5, and so 7, the number inside, is going to be raised to a fractional exponent, not 1/5, but 7/5. If you have trouble seeing this, another way of writing it is like this. The inside is 7 to the 1/5, and we have 1/5 now times 7 because it's power to power. So 1/5 times 7 would give us 7 to the 7/5. Okay, so again, we just demonstrated these two are going to be the same thing. All right, and then how about something like this? Well, this is 13xy, all of that raised to the 25th third power. Remember, the index is the denominator of the fraction. All right, great. Okay, getting that down pretty well, hopefully. All right, if we have negative exponents, we got a couple things going on. Negative fractional exponents, that negative is just going to drop it downstairs. All right. So this is just going to be 1 over 49 to the positive 1/2, which means 1 over 1/2 power of 49 means the square root of 49, which is 1/7. That's the idea. And if we throw some exponents in there and some ugly fraction there, this is going to be 1 over, because of the negative, all of this is going to go downstairs, 31xy to the 5/21st power. And we're not going to clean that up because the 21st power, that's just going to be something ugly. We could distribute that out, kind of, not really distribution, but we could hand that out, pass that out. But we don't need to. All right, anyways, the key is there. If it's negative, it drops it downstairs, and the fractional exponent applies. All right, well, there you have it. So that's how we use rational exponents. So in the next video, we'll do some examples there that can help you out, but that's how we use them.